Today we're going to talk about the place value chart and powers of 10 and how our numbers shift in different directions and change values. So go ahead and write the date into your notebook, and we're going to write place value shifting and powers of 10. This is MBT 1 and MBT 2. And this is going to be page 30 for me. All right. All right, so we're going to take a look at the sheets that I gave you. And on the first page it says, how is the value of the digit 2 in the number 15 and 42 hundredths different from the value of the digit 2 in the number 12 and 54 hundredths? Explain using mathematical vocabulary but based on place value. Okay, so I know that these are my two numbers that I'm working with, and I know that I need to explain using mathematical vocabulary based on place value. And I know that I'm comparing the digit 2 in both of these numbers. Okay? When I think comparing, I think I need to line the numbers up. So I'm going to do that over here. 15 and 42 hundredths, 12 and 54 hundredths. When I look at the 2, here's the 2 here, and here's the 2 here. This is in the hundredths place. This is in the ones place. So they're in two very different place values. Okay, I know that this 2 is 2 place values further to the right than this 2. Okay, 2 place values further to the right. Okay, so the value of this 2 is 2 wholes. The value of this 2 is 2 hundredths. Okay, so that's the first thing I'm going to write. The value of the 2 in 12 and 54 hundredths is 2 wholes. The value of the 2 in 15 and 42 hundredths is 2 hundredths. And really, I know that each time I shift place values in either direction, we're talking about powers of 10. So I know that a shift 2 place values to the right means that this 2 is, I would technically take 2 wholes and divide it by 10 to the second power because it shifted 2 place values to the right. So that would say that 10 to the second power, if I think 10 to the second power, that equals 10 times 10, which equals 100. So this is actually 100 times less than the 2 in the ones place because it's 2 place values over. It's not 20 times less, but it's 100 times less because of my powers of 10. So I could say 2 wholes is 100 times greater than 2 hundredths, and 2 hundredths is 100 times less than 2 wholes. Okay? And I explained it in terms of place value. We're not going to worry about number 2. Okay, we're going to look at number 3. Annie had the answer 35 and 65 hundredths showing on her calculator after dividing a number by 10. What was the original number? Explain how you know. Okay, so I know that she took some number, divided it by 10, and she got 35 and 65 hundredths. Okay, how do I figure out my original number? Well, I work backwards. 35 and 6500ths times 10 will give me my question mark. Okay? So if I look, 35 and 6500ths times 10, that's like 10 to the first power. That means that all my digits would shift one place value to the left because I'm multiplying. Okay? So that would end up being 356 and 5/10. Okay? Remember, if I take my place value, and look at it place value by place value, if all my digits shift one place value to the right, that would mean the 3 would be here, the 5 would be here, the 6 would be here, and the 5 would be here. So it would be 356 and 5/10. Okay. Now, let's look at these. It says explain what happens to the value of the digits when multiplied and divided by a power of 10 using the two examples below. Okay? What happens to the digits? Here, all digits shift 3 place values to the right, and the number's value becomes smaller. I want you to take this number and try to make a comparison or a statement similar to this one, but tell what happens when we multiply and what happens to the value of the number. Okay? Then I want you to choose either number 5 or number 6 and try to solve it on your own.